Good morning, afternoon, or evening. Day five. Okay, yesterday was a work period on the power rule of derivatives. So we're going to get into the next rule now in day five, and that's the product rule. Okay, so that's like before when you were doing the polynomial rule, power rule, and you had something like, say, 9x squared plus 1 times 3x squared minus 1. You'd have to expand that out using FOIL and then do the derivative. Well, now there's a shortcut method you can do, which is called the product rule, that you don't have to expand everything out. And sometimes it's easier to expand it out and use the power rule. Sometimes it's easier just to use the product rule. So what we're going to do is I'll state the product rule. We're not going to really derive what it is, but we will state the product rule, and then we'll do some basic examples of how to do product rule. We'll do some polynomial examples here. We'll do some examples with three products rather than just two. And then we'll also do some examples where you may have to find the slope of a tangent line and all that kind of stuff. So we'll probably go into around that 40-minute range again today. And tomorrow will be another work period, which will be our standard for this unit, doing that for a few more days until we get through all the rules with derivatives. So let's state the product rule. So the product rule, if we say that if you have, say, two functions, one, say, is f of x, and it's multiplied by another function, say, g of x, okay, say, the derivative then is found using, okay, so what it is pretty easy. It's f of x prime, which means derivative of f of x. So we'll use the prime symbol for derivative. That would be, where's my prime symbol? That one there. Okay, times g of x. Actually, got that wrong. F of x. It doesn't really matter, actually. And then we'll go g prime x. This is how I want the derivative to have the prime in there. So we take the first one and we multiply the derivative of the second one, and then we add it to the first one's derivative, f prime of x, times g of x. And that is what the product formula is. So it's the derivative of one times the other expression, and the other expression's derivative times the original expression. So I like to shortcut it. I like to say that the product rule, if I was to write it, I have a shortcut method of writing it, and so does a lot of calculus. But instead of using f of x, we just say f g prime plus f prime g equals y prime. So that's the product rule. And that's how I'll write it most often. Okay, so let's do some examples. Okay, I like to break it down into parts and then do my product rules. But some people will do them all in their head. But I would recommend breaking them down to start with. So let's do our first example. Let's say that we have the expression of a simple one. Let's say that y equals 9x squared times x cubed minus x squared minus 7. Now we could just go like this and then do easily do the power rule if we just expanded it. But if we didn't want to expand, we could use the product rule. So we know that if we say that f is equal to this first one, 9x squared, And if we say that g is equal to the second one, x cubed minus x squared minus 7, we could then figure out what f and g prime are and then apply this rule. So f prime would be 18x, like that. And then g prime would be 3x squared, so 3 out front, 3 using the power rule, x squared minus 2x. Okay, and that would be the 4 parts that we need. Now we would just apply the product rule together. Now, so apply the rule. Okay, and we've got f, so that's 9x squared, so it's y prime equals 9x squared times g prime, which I didn't put the prime, but I should have. It's 3x squared minus 2x plus f prime, which was 18x, times g, which was x cubed minus x squared minus 7. Okay, now that's the first line. Now, a lot of times I'll say do the first line and leave it in first line form. But we can simplify this easily by expanding this one. Some of them we don't simplify any farther, but some we can. So this is 27x to the fourth minus 18x cubed. Okay, plus 18x to the third minus 18. Oh, I put squared and this is a cubed, right? You got to be careful. Like you can see, I better be careful with the powers, right? You can see how I make mistakes in these, but you got to be careful. So that would be x cubed because it's there. So that's x to the fourth. This would be then x squared, so then it'd be 18x cubed. And this one would be 17 times 18. What's that? 70 56, 126 or something. 18 times 7, 126. Yep. Negative 126x. Okay, some common ones that we can apply together. 27 and 18. That's 45 x cubed, or x to the fourth, pardon me. Okay, and then the x cubed, we got minus 36x cubed. Okay, we did the x fourths already, and then we've got a minus 126x. So that's the product rule. Now, sometimes I'll say don't simplify past this. I'll just say leave it in first step form, depending how complex it gets. In grade 12 calculus, we sometimes don't necessarily need to simplify. When it's a simple simplification like this, we can do it. When it's really complex, that's more of the university level type stuff. Okay, let's do another one here. Okay, let's see here. Let me dig out my little more complex one. Let's do a polynomial one with a root in it. Let's throw a root in there. Let's say that we have so I've got one here, 5x to the fourth, okay, minus 2x to the negative 1, okay, plus x, times, let's do a root 3 to the fourth root of x. Okay, let's use the product rule for this one. So if we write this out, 5x, well, let's do our f and g, because we can convert this as we're writing it. So f equals 5x to the fourth minus 2x to the negative 1 plus x. So f prime then is going to equal 20x cubed. Okay, 4 times 5 is 20. 4 minus 1 is 3. And negative 2 times negative 1 is positive 2. X to the negative 2. 1 minus 1 is negative 2. Plus 1. Derivative of x is just 1. Okay, now we'll do g. And let's write g in the form of an exponent. So this would be x to the 1/4. There's our g. And our derivative of g prime. Okay, so then if we take the derivative of this, it's 1/4 x. Okay, and we go 1/4 minus 4 over 4. So that would be negative 3/4. Okay, so there is our pieces that we need in terms of what we've got there. I forgot the 3 there, didn't I? Good thing I looked over on my side. I forgot this 3 here. I've got 3 here. So this is going to have a 3 here. So that's going to be 3/4 x to negative 3/4. Okay, because don't forget your constant out front like I did there. When I rewrote it, I just rewrote this part, not that part. So, okay, so let's now apply the product rule here. So it's f times, now, as you may notice, the order in which these go doesn't matter. You can do f prime g first and then this one. It won't matter because it's a plus sign, but we'll stick to the way I've got it written there. So fg prime plus f prime g. So y prime then is going to equal, f is 5x to the fourth minus 2x to the negative 1 plus x multiplied by g prime, which we have to fix up because I forgot that. So 3/4 x to the negative 3/4. And then we're going to add it to f prime, which is 20x cubed plus 2x to the negative 2 plus 1, all multiplied by g, g. So g was this 3 times x to the 1/4, or 1/4 power, not 1, like that. Okay, now you're like, okay, well, that's great, but how do I simplify? How do I multiply these up? You don't need to go any farther than this. In grade 12, we can stop here. If you want to simplify farther, then you have to start thinking about, well, what does this mean and what can multiply? If you're multiplying it, obviously you're going to get, okay, 3/4 times 5. I'll just do a quick example of how it would simplify with just one multiplication. But we're not going to do a whole bunch. So you'd go 3/4 times 5 first. That would be 15/4. And then you would go, okay, when you're multiplying exponents of x, you add them. So this would be 4 plus negative 3/4. So that would only be 3 1/4. X to the power of 3 1/4, which 3 1/4, if you look at that, that's 13/4. Okay, so you'd end up getting 15/4 x to the power of 13/4, and then you continue on doing it that way. So we're not going to do that extra simplification step. It takes a long time. You turn your page sideways, do all that kind of stuff. So this is as far as we go most of the time when I say, do not simplify or something like that. So if I say do not simplify, you just go this far. okay, which is typically what we'll do because that's a tough simplification. Okay, and a lot of students always ask me, how far do I go? How far do I go? Well, if it's something really complex, I usually don't get you to simplify it any farther because it just takes up time. But if it's something like this where it's real easy simplification, you can go ahead and do that. Okay, so that's an example of the product rule with a root one in there. Let's do an example with a double root one here in it as well. And then we'll do one with three products in a row. So let's say that we had y equals the root of x plus 1 over x as a multiplied by x cubed minus the cube root of x. Okay, and we're going to say find the derivative, don't simplify. No simplification. Use product rule. Maybe I'll make a video of me simplifying some complex ones if you're interested, because that's what the university level will be, is where you have to go right down and simplify everything with all the rules of algebra. So let's say that f equals, let's rewrite this, is x to the 1/2 power plus x to the negative 1. Okay. So then if we do f prime, then that's going to equal 1/2 x, okay, half minus 1, or half minus 2 over 2 is negative 1/2, plus, which in our case, plus negative 1, x to the negative 2. So there's our product. Our product, there's our derivative. Pardon me, we haven't done the product yet. And the g part is x cubed minus x to the 1/3 power. So let's do g prime. Okay, so that'd be 3x squared minus 1/3, and we go 1/3 subtract 3/3 is x to the negative 2/3. Okay, so there is our, and if we just want to leave it in factored form, that's another thing I'll say, leave it in factored form, which I mean just putting these together in the product rule now. So f g prime plus f prime g. Okay, f is x to the 1/2 plus x to the negative 1. Okay, and the g prime is this one in the bottom here, 3x squared minus 1/3 x to the negative 2/3. Okay, and then we have the plus sign. F prime is this one up top here, 1/2 x to the negative 1/2 minus x to the negative 2. Okay, you don't have to put the negative 1 in there, but you can if you want. And then our last one is g, which was this x cubed minus x to the 1/3. Okay, simplifying this would be a nightmare. But that'll be university where you multiply everything out using FOIL. Okay, so that's our example. So pretty straightforward, and this is probably where the complex I'll get. I won't get you to simplify things like this. I'll just say do the first step, leave in factored form idea. So the next thing I want to get into then is how do we do triple expressions when we have more than just, if we go back here, what happens if I have more than two expressions? What if I have three products? Well, the order in which this is, it doesn't matter. So if we have three products, basically it follows the same pattern here. It's the two products times derivative of one, two products times derivative of another one, two products times the derivative of the other one of the original expression. So what does that mean? Well, let's rewrite the triple way. So this is an example of a three expression product rule. Three expression Okay, so the three expression product rule, if we have y equals a times b times c, then y prime would be a and b times the derivative of c plus a and the derivative of b times c. So now we're going to do the derivative of a next, plus a prime times bc. So each one of them has one of them you have to take the derivative and the other two multiply it together. So that is the general idea of the three expression product rule. Okay. Now let's do an example of that from I'll just make one up here. Let's see. Let's make a simple one. Let's say y equals x squared times x cubed minus 8 times 3x plus 5. Okay, and let's do this one using this rule so that a equals x squared, so a prime equals 2x, b equals x cubed minus 8, so b prime equals 3x squared, and negative 8 is 0 for a derivative, and c equals 3x plus 5 times, or not times, c prime, what am I saying? That would be 3x, would be 3 for the derivative. So it would just be a 3, because there's no x with the 5, that would be 0. Okay, so then if we do the actual derivative here, okay, so a is x squared, b is x cubed minus 8, and c prime is 3, plus a is x squared, b prime is 3x squared, okay, and c is 3x plus 5. Okay, and finally our last one here, plus a prime, which is 2x, b, which was x cubed minus 8, and c, which is 3x plus 5. So if I said leave it in factored form, you could stop there, and that would be good. Okay, but let's simplify this one because this one isn't too bad to simplify. And I'm just going to check my, as you probably heard there, what came in there. Okay, no problem. Sorry there, guys, but we'll get back to the. Okay, so let's simplify this one because this one's a little bit easier. So 3 times x squared will go 3x squared times x cubed minus 8. This one here we can go plus 3x to the 4th times 3x plus 5. This one, let's do the FOIL over here. 2x. Got to make sure we don't make any errors. This is typically where you can make a silly error by forgetting something. I do quite often, actually, so keep an eye on me. 3x to the 4th, if you multiply those two, and then plus x to the 3rd, plus 5x to the 3rd, minus 24x, minus 40. Okay, so this one's going to be 3x to the fifth minus 24x squared. Okay, this one's going to be plus 9x to the fifth plus 15x to the fourth. Okay, and then this is where we're going to get the multiplying it out here, plus 6x to the fifth plus 10x to the fourth plus a minus 48x squared minus 80x. Okay, so let's see, do we have any of these that are common? We have x to the fifth here and here. And we got x to the fifth. That's it. So that's 11. And what do we got here? 3, 9x to the fifth. Okay. Hopefully I didn't make any errors in there. Okay, and then we got the fourths. We got 10 and 15 plus 25. Any more fourths? Oh, here's a 9x to the fifth. So that's 18x to the fifth. See, this is where you got to be careful when you're simplifying. So we got 3, 9, and 6. So that's 15, 16, 17, 18x to the fifth. Okay, and then we've got a 4 there and a 4 there. So it looks like 25x to the fourth. And then we've got a x squared. So we got negative 48 and negative 24. So that'd be 60, 72. And minus 80x. Okay, so that one, pretty complex, but most of the time I'm not going to get you to simplify it. I'll get you just to keep it in this first step form. Okay. Let's do one more example. We got, so if I want you to simplify, like if I give you a question and I say, find the derivative, do not simplify, you would stop right after this first line. You wouldn't bother doing all this stuff. Okay, which is what I commonly do. Okay, and the last type of example I'm going to do is one of those where you have to do finding a tangent line at a curve. So then you're using the derivative. So let's say find the equation of a tangent line. Okay, to the curve, and we'll put it in product form so that we use the product rule. Y equals, let's make it real simple so that 3x plus 5 times I don't know. Oh, let's go x squared minus, or let's go x minus x squared. At x equals 1. All right, so the first thing we've got to do, step 1, is find the point. Okay, most people would probably just expand this out and use the power rule because it's just a simple one, but we're not going to do that. So step 1, we're going to use the product rule because we're in the product rule section. Okay, so find the point because we need the point and the slope, right? And then we can find the equation of tangent line. Okay, so let's put the 1 in here for x. Y equals 3 times 1 plus 5, all multiplied by 1 minus, oh, I'm going to get 0, aren't I? That even makes it better. 1 minus 1 squared. So this is going to be 3, 8 times 0 equals 0. So my point then is 1 and 0 for this particular expression. Okay, now we need to find the slope. Find the derivative. Okay, so the derivative is, let's write this whole thing out so that we know what we're doing. 3x plus 5 times x minus x squared. So f equals 3x plus 5. So f prime equals 3. Okay, nothing with the 5 there. G equals x minus x squared. So G prime is equal to derivative of that 1 minus 2x. Okay, and now write the derivative in product rule form, pardon me. So f g prime plus f prime g. So 3x plus 5 times g prime, 1 minus 2x, plus f prime, 3 times g, which was x minus 2, or x squared, pardon me, not 2x. Okay, now that's y prime. So now we're just going to plug in at the point 1. It says at x equal 1. So we're going to have to put a 1 in here and figure out what the slope is. So the slope is going to be 3 times 1 plus 5 times 1 minus 2 times 1 plus 3 times 1 minus 1 squared. So that's going to give us a 0 there. So this is going to give us 8 times, so 1 minus 2 is negative 1, plus 3 times 0, because this is 1 squared is 0, so then it's going to give us equals negative 8. So our slope is negative 8. So once we've got the derivative and we plugged in our value for it, and we've got our point and our slope, we got to remember where our point is. It's all the way up here, 1, 0. So then we're going to use the y minus y1 equals slope times x minus x1. Okay, and my point is, don't forget what it is, I'll write it here, 1, 0. Okay, and my slope is negative 8. 1, 0. Okay, so y minus 0 equals negative 8 x minus 1. Okay, there's my point, right? 1 goes there and 0 goes there. So y equals negative 8x plus 8. There's our line equation. If we want to put everything over here, y plus 8x minus 8 is equal to 0. I just added 8x and minus 8 from both sides. There's our line equation in standard form. Okay. All right, so I think I'll just take a quick look at my notes here to make sure I didn't skip any one. And no, I think That covers all the types of stuff in the product rule area. Okay, so next day I will be some practice with the product rule. Let's just do a quick review here. Okay, so for the product rule, if you have f of x times g of x, two expressions multiplied together, you can simplify and find the derivative by doing f g prime plus f prime g, or you could switch these two around, it doesn't matter. So we did a couple examples of that. We did an example with just simply simplifying it. We did an example with a root in it, and we just stopped because simplification was difficult. So I just say do not simplify, or I say simplify when it's simple. Okay, and then we did another example like that, and then we did the three expressions together, which would just be, I should have an equal sign in here, sorry. Okay, it would be just the two first ones times the derivative of the third one, the two first and third times the derivative of the second one, first derivative times the second and third expressions. Okay, and then you can simplify when it's really simple like these, but most often I just get you to leave it in factored form. Even when you're doing these questions where you find the tangent line to that curve at x equal 1, what you do is you find the point, and then you find the derivative, plug in the value of the derivative and find what the slope is, and then use the slope and point to find the line. And that is it for today. That's about 37 minutes in. So tomorrow on day 6, we will be working through practicing some work with the product rule and working it out. Now, when you do look at the solutions for those practices, you have to be careful. I think there are some errors in some of the solutions there, so keep that in mind when you're doing them. So if you want to double check with me, I wasn't sure about this or that, and the answer said this, you still might be right. There's a few errors here and there throughout the units, as you probably noticed already after doing 2 units. Keep that in mind. Good luck.